Hello, it's me again, Dennis. And today, we're going to do a performance investigation. And this time, trying to analyze this performance issue that I encountered when using Sentry. Sentry is an error monitoring. So that issue encountered it is in this page under session replay. And as you can see in here, there's a this is the right pane, and there are tabs, so breadcrumbs. You can see the events here, console, because it's a session replay. Okay, network tab based on the replay that gathered, and then errors trace. Let's go back to the breadcrumbs, and as you can see, this search bar, whenever I type here, this is it's quite it's quite slow, especially smash it. See that one? It's slow. And let's see. Let's see. So I open the developer tool. By the way, I'm using Chrome Dev, and I am in the performance tab. And here, it's the interaction to next pane. So you can see here the durations of, let's say, whenever I let's say whenever I trigger a user input, the interaction to next pane will calculate the durations of that response. So let's type that, and as you can see in here, this is keyboard, means keyboard event or key press, something like that. It took 232 milliseconds. That's the 232 milliseconds for INP. That's quite a lot. So when I type that one, that's the duration, and then the others are it took 136 milliseconds. Problem here is that whenever you type, I mean that's quite, me personally, 144 milliseconds for typing. That's quite a lot, because whenever you type faster, then you are now getting you can feel now the delay. See that one? Because I type faster compare a while ago. Okay, and it's not good. See, the faster you type, the worse it gets, the performance. Okay, so what we're going to do today is to investigate the performance issue. So let's go here, and we have installed React Developer Tools here. So this application is using React, and one of the things that I'm trying to do whenever I start analyzing the performance of the app is, especially if it is React app, is to check the render update. So there's an option here. When we enable this one, it highlights the components that gets re-rendered. So we enable it. So you can see here, if the components gets rendered, then it will highlight. Let's type D. See that one? I mean we can say that it renders everything, right? And I mean, just for enabling this, you could create an assumption that that's the reason why that INP is quite slow. I mean that INP took a lot of time. It is because it re-renders the components. And then once I check that re-renders through enabling this in the React Developer Tools, the next thing that I'm trying to do is to go to the performance tab and then enable this profiler. At least when enabling the profiler, we can dig down to that issues. We can basically get some informations like functions, that what are the expensive functions that took place when there's a user input event, you know. And because we know that there's a performance issue, then the next thing that we can do here is to do profiling, just like I said. Okay, so let's enable this, or let's do profiling, and then let's type depth, and then stop. So with performance tool, and you know, the beauty, the good thing investigating the Sentry is that the source maps are, it gets downloaded by the user. Okay, obviously I'm not sure if that is, I mean, because downloading source map could, that's a resources from the by the users that needs to pay. I mean, I downloaded that once, it took time for me to render this or to load this application because of the source maps. Okay, but the beauty of having source maps is that you can easily analyze the functions, because without source maps these are obfuscated. Okay, the function name will be transformed into something that is quite cheaper, because yeah, it's minified. But because there's a source map, so we can easily, not easily, but we can analyze, we can determine what are the functions. Okay, so here you can see these red bars. So there are 4 red bars, and this is key press, right? And when we say key press, that's a key press event. So whenever we type here, it will trigger a key press. Okay, so per key press here, it took 194 milliseconds. The other is 159, and then another key press event took 138, and then this one is 245 milliseconds. And you can notice here that they are on the same bar, unlike to this. And the main reason being is that these first 3, for every event, okay, the browser tries to paint. Okay, it tries to, you can see in here, where's the paint? Oh. Let's try to check here. So basically there's no paint happening here. Yeah, but yep, but most likely if you can see a separate bars like this, meaning that there's a frame that is created for this bar. But for now, I think that it should be like this, right? Because there's no paint, meaning that instead of, let's say when we type D, okay, it should render this D, okay, and then E, render E, and then P. But because there's no paint that happened here, meaning that, and there's no paint here between the task, and the paint happened after the second event, so meaning that browser patched that update, so we get something like this. It paints the T at the same time, right? Which is not good. That's basically not good. That's also the same here, because they get overlap, something like that, and the paint happened. And this is quite common, especially if the user input event handler took a lot of time. So for the main thread, instead of creating frame per user input, it cannot do that because it's quite busy doing it, so it just tried it to batch that update. So it commits, instead of having 2 frames, it only, did or produce 1 frame. And yeah, 194, 159, that's not good. And let's try to focus on this key press event, and let's see what are the functions that are quite expensive to run. First thing that we can notice here is that this function called below, it's a dispatch discrete event. These are functions coming from the React DOM. Okay. So meaning that, because this is a React app, right? So it is quite obvious we're going to it. But these are functions coming from the React DOM, and it took 101 milliseconds. This one, okay? And the main reason why it took 101 milliseconds is because of the functions below. This is call stack, right? This dispatch discrete event calls these functions below, and those below functions, most likely, let's say, the leaf functions. When I mean the functions, they're at the bottom of the call stack. Most likely, they're the one who that causes this kind of durations. Okay. But mainly, we can clearly see here that this match routes took a lot of time. It's 33 milliseconds, and this match routes is coming from this navigate function. And I believe, yep. So this, match routes took 33 milliseconds, and that is it called by the navigate function. And this navigate function is coming from the React router. So React router is the library that the Sentry app uses. We can confirm that one here. So we click the navigate, click this link, and then I think we can go to the top. Yes, this is router. You can say React router. See that one? React router. Remix run React router. So this is the library that it uses. Meaning that this expensive function is not driven by the source codes, but driven by the library itself, which is quite expensive to run. So if I'm going to optimize this page, one of the things that I need to consider is to investigate this one, obviously, and going down to the call tree. These flatten routes and flatten routes, these are the functions, basically the main culprit on it. On that duration. It is quite heavy. You can ask AI like this to, let's say, on this stack starting from navigate, you can ask calculate the total duration of the flatten route function. So it's 8 milliseconds. How about the flatten routes? I think it should be flatten routes. How about flatten routes? I don't think that's not. Yeah, I think that there's a problem. Or maybe this match route branch. Let's go. Match route branch. Calculate the total duration of match route crunch 26.8 milliseconds. So for flattened routes, yeah, that's correct. Yeah, I think that's correct. So flattened routes took 8 milliseconds, and then match route crunch took 26 milliseconds. It says, right? 26 milliseconds. Yeah, it's something like that. So I think that's correct. Correct. The A was correct a while ago. So that took time. And then again, there's a call of match route. So whenever the match route gets executed, obviously, it will take time. So just like I said, if I'll try to optimize this, this is one of the things that I'm going to check. These match routes. Yep. So here, match routes was invoked by the navigate function, and then in this one, it gets invoked inside this hook use routes implementations. And these are this is a function that is called behind the scene, I believe. So check the React router DOM. Yep. But obviously, this took 194 milliseconds, and this is only for 32 milliseconds, 37 milliseconds. Let's see. Let's ask AI again. Total computation of match routes 70 milliseconds. That's quite huge. So 190 milliseconds, 70 milliseconds, almost half. Or not half. not half, but I don't know how many percentage is that. Maybe 35, somewhere like that. That's still quite a lot, right? So the rest is re-rendering. We saw a while ago that gets to render everything, right? Most of the components gets re-rendered, and we can confirm it is because of this function. So this flash sync work, perform sync work on route, render route sync. These are functions that are called inside React router. Okay, and this is part of the render pace. So begin work, in this function, the component will be called, and we can confirm that one. Let's say in this one, this data routes is a component. Let's go to here. Yep. You see, data routes and renders this use route implementation, which is the hooks. Use routes. Okay. So that's a component. So it gets rendered. Basically, this function gets called inside this render with hooks function. Okay. So this is a component gets called gets rendered, and then other than that function, excuse me, the app also gets rendered. As long as you can see this render with hooks function below that one, the function will be a component. Okay. Let's render this app component, route analytics, context provider, global drawer. Excuse me. And then the org drop down. There's a lot of components. Primary navigation help component, onboarding item, user drop down. Yeah. And then the commit pace. Also try to check. Excuse me. Wait, I'll just get water. first. Okay, just stand by there. And I'm back here. I'm back. Sorry for that one. Just dry cough. Where are we now? Okay, so just like I said, this match routes function took a lot of time to execute, and then with begin work below it, we can see in here that there are a lot of components that gets called, right? So that's a render. And then this function, what else? So in this, we're still the same stack, yes, same stack. And then in this one, below this dispatch the script event, render root sync, another render with hooks. So this replay details component gets rendered. Focus tab, but as you can see here, their duration is not that slow, right? But let's say this one, it's 0.88 milliseconds. Even that this is just 0.88 milliseconds, but considering that there's a lot of components that gets rendered, let's say 0.88 milliseconds, but that's 20 components. That's still expensive, right? Because there's a lot of components. So it's okay to just ignore this render if there are, there are just few components that got rendered. But in this case, there's a lot of it. Okay, and you can easily confirm it through this one. Let's say you just go to this to this begin work. Okay, I mean here, let's say this one, begin work took 23 milliseconds. Most likely the contributor of that duration inside that begin work are components. So see that one, and yeah, components. This one, serialized styles, because these functions will not be invoked if the component got bailed out, and same stack here, render root sync, begin work again, right? Took 23 milliseconds. So if we can reduce the number of components that got re-rendered, okay, I mean, just if we can reduce those components, then we can cut the duration of the begin work. And that's the reason why it is quite important to memorize the components, or maybe just try to create or define a good architecture that avoids this kind of re-rendering. Okay, there are patterns that you can use, like children composition, instead of doing some black box component. Okay, and then here, this commit, this one, you can see this commit root. So this, the layout effects use effect, those callbacks, they are invoked in the commit phase, right? And those functions will be invoked here. This one, commit root. Let's say commit layout effect on fibers. This is the layout effects, and it also took 27 seconds. So that's another area that you need to check. And I think that's it. So the things that we discovered on this call stack we can just use it on the same call because these are the same, right? It gets triggered by the same user input event. This one by post message. To be honest, I'm not quite sure why is this post message, but the same thing. If you're going to go deeper, the culprit are just the same. It's match routes, right? What is this? Okay, worker handler. Add event. Add event sync. It's a worker. It's weird. It's worker, but get run or got executed in the thread. But obviously, yes, because if these are functions that will be or that should be invoked in the main thread. So yeah, I think that's it for this performance stub. Just like I said, based on that analysis that we just did, there are 3 things that we can check if we want to optimize this performance. One is this match routes function. It took a lot of time to execute, and this function is coming from the React router. Second is the begin work. So begin work meaning components. Okay, that's the culprit. Re-rendering of the components, and we can see a while ago that there's a lot of components that gets re-rendered. And then third is the commit phase. So double check the layout effects and the effect callbacks. The thing here is why this component, or why some, I mean, yes, we know now some of the functions, or the main functions, right? Main functions that contribute that kind of duration, but we still don't know why this navigate function gets executed, why these components get re-rendered, what happened, right? Let's go here on this page and let's try to type. So whenever I type here, it gets rendered everything, right? You can also notice that the URL here gets changed. Look. And that's the reason why the component gets re-rendered. It is because the URL will be updated. So it synced. So it tried to sync this search query, okay, this search key with this search bar. And with React router, because I'm using React router, there are hooks that are that will be executed or will be invoked whenever the URL gets updated, and whenever that hook get invoked, meaning the component also get rendered, right? Yeah, because it's a subscription. So there are hooks from the React router observes a URL state change. Whenever there's a state change, the component that consumes that hook will be re-rendered. So, I don't know the React tree. I mean, we can basically see here the React tree, right? But unfortunately for us, it's obfuscated right now, so it's hard to analyze. But we can think about it something like there are components at the top that are subscribing to that state subscribing to the state URL event. So whenever it gets updated, that URL, that component also gets rendered, and somewhat maybe the way they design their React tree of this page, it's like a block box, something like, when I say block box is, let's say, let's go to the Xcode row. Let's confirm. Let's say this is parent, and then child 1, and then child 2, and then this is consumes that hook. Let's say maybe use hook, or yeah, I think that use location from React Router, I don't know if there's still use location, but let's say this is the hook, use hook, where consider that this hook subscribe to that URL state change event, and then this parent renders this child, the same thing with. So when I say block box is something like they're on the same box, right? So I mean these children, they're on the same box because parent encapsulated these two components. So, and this parent also is subscribing to this hook. So whenever there's a state update on this hook, the parent component gets rendered, and that's also the same with child 1 and also child 2. If child 1 doesn't rely to the data of the use hook, then that is quite unnecessary for child 1 to re-render, right? Because it gets the parent gets rendered because of there's a URL state update here, but child 1 doesn't need data from the hook. Okay, but because parent is the owner component of this child 1, so it, child 1 will be forced to re-render, and that's also the same with child 2. But with children composition, something like passing this JSX element of the child 1 as a prop of the parent component, then whenever subscription, if they can do that one, then that would be better, right? Because whenever there's changes on the parent, that child 1 will never be re-rendered again, right? So that's children composition, and this is a box pattern. It's a so yep. So I think the way this React tree, is defined, something like that. So it triggers re-rendering at the top, renders lots of components located below of that components, right? So yep, they need so what I can suggest here is maybe they can instead of syncing, something like that, you can see whenever we type, tries to sync that URL. Been thinking maybe they can just do some debounce here before updating the URL, right? Just use debounce. At least it will not try to sync the URL to the value of the input bar until the user stops typing. At least on that one, you can avoid making the main thread PC. But still, even with the bounce, the consumption per user input per key press is still quite expensive. So other than the bouncing this user input just to delay the update on the URL, it's also good to check these match routes, just like I said, and then the rerender and the commit functions that gets invoked in the commit phase, which the layout effects and also the passive effects or use effect. And you can see in here it's mostly layout effects, right? I'm not sure why, but yep, that's our investigation for today, and thanks for listening.